Hello, everyone. Today is the last day for this unit. This is Notebook Check 63. Entry. Our unit test is this week. So be prepared and have your notes ready so we can go ahead and knock this out. Today we're learning 8-4 linear functions, graphs, and models. Linear functions, graphs, and models. We want to interpret the meaning of the terms relations, functions, domain range, independent variable, and dependent variable in mathematical exposition. Want to use function notation. Function notations when we talk about f of x. Want to identify a linear function and graph it. Perform cost analysis to an equation using linear functions, and construct a linear model from a set of data points. So first off, what's a relation? A relation is a set of ordered pairs. And if we notice, our ordered pairs are written in the form of x comma y. So when we refer to an ordered pair, again, we're referring to ordered pair in the form of x comma y, which is our ordered pairs. So for example, it says f, you have 1, 2, -1, 5, and 4, 3. Remember, this means the set. Okay? That means the set. So when you see this little squiggly line right here, it means the set of. All right? So the set of ordered pairs, 1, 2, -1, 5, 4, 3. And G equals a set of ordered pairs, 1, 5, 9, 0, 9, 8 are both relations. Y was a relation. It's a set of ordered pairs. Terminology. If the value of the variable y depends on the value of the variable x, then y is a dependent variable and x is an independent variable. So y will be our dependent variable. And our x will be our independent variable. Remember, y depends on x. X can stand alone, y cannot. A function is a relation in which for each value of the first component of ordered pairs, there is exactly one value of the second component. So in other words, in order for something to be a function, remember, relation is a set of ordered pairs. In order for it to be a function, it says exactly one value of the second component. It says the first component of the ordered pairs. First component means the x of the ordered pairs is exactly one value of the second component. The second component is the y value. Okay? So which means x value, and I'm going to write this here, make sure you know this. In other words, the x coordinate cannot repeat. It cannot repeat in the relation. So if you notice, f has exactly one value for x assigned to the second component y. For g, for that relation, the 9s repeat. So because the 9s repeat, g cannot be a function. F is a function. So g is not a function. And f is a function. Because the x coordinate cannot repeat. In a relation, the set of values of the independent variable x is known as the domain. And the set of values of the dependent variable is known as the range. So again, in our order pair x, y, x is the domain, y is the range. The graph of a relation is the graph of its ordered pairs. So you're going to get your ordered pairs from your relation. You're going to put them on the graph. And you basically graph your relations. Basically, you're graphing a set of ordered pairs. The graph gives a picture of the relation which can be used to determine a domain and a range. So again, domain, we're going to look at all the coordinates on our x-axis. If our range, we're looking at all the coordinates of our y-axis. A function is a relation in which for each value of the first component of ordered pairs, there is again exactly one value. Value of the second component. A function is a set of distinct ordered pairs in which no first component is repeated. So that means the x-coordinate cannot repeat. I mentioned that in the previous slides. A function is a rule or correspondence that assigns exactly one value to each distinct domain value. So remember, if you can remember the x-coordinate cannot repeat, only the y-coordinate can repeat, then you'll be able to determine which relation is a function. Function notation. When a function f is defined with a rule or an equation using x and y for the independent and dependent variables, we say y is a function of x. To emphasize y, it depends on x. So we use a notation. Instead of using y, we say y equals f of x. And it's called function notation. And again, to express this is read as f of x. So f of x. For example, if y equals 3x plus 1, then we write f of x, because remember we're replacing y with f of x, equals 3x plus 1. So all we did was substitute the value of y for f of x to write it as function notation. Note that f of x is just another name for the dependent variable y. If f of x equals 3x plus 1, we find f of 2 by replacing x with 2. So we'll write this as f of 2, and in place of x, we're going to write a 2. So we had 3x plus 1. In place of x, we're going to put a 2 plus 1. 3 times 2 is 6, plus 1 equals 7. Therefore, f of 2 is read as, again, f of 2, or f at 2. There go f at 2 equals 7. Let's look at example 1. Example 1 say use function notation. So we have f of x equals x squared plus 3x minus 1. So we want to find the following. We want to find f of 2, f of 0, and f of 2x. I don't know why I got on that second line, but I'm just going to write it up here. It shouldn't be on the second line on your screen. So, I don't know. I'm just tripping on mine. So, f of 2, we're going to replace the function. Remember, the function is x squared plus 3x minus 1. So, everywhere there is a 2, we're going to replace that. So, 2 squared plus 3x minus 1. 2 squared plus 3 times 2 minus 1 equals 4 plus 6 minus 1, which equals 9. F of 0, we have 0 squared plus 3 times 0 minus 1. That gives us 0 plus 0 minus 1, which equals negative 1. And f of 2x, so we have 2x raised to the second power plus 3 times 2x minus 1. That equals 4x squared plus 6x minus 1. So if you notice, I have to leave it like that because I can't combine like terms. That's in its lowest written state of degree. Number 12, or slide 12. Linear function, a function that can be written in the form of f of x equals ax plus b. For real numbers a and b is a linear function. Linear means it forms a straight line. So for example, 2a, we're going to graph the linear function. F of x equals negative 2x plus 1. First thing we're going to do is graph the y-intercept. So remember, y equals mx plus b. B is our y-intercept, so we have f of x equals negative 2x plus 1. So my y-intercept is 0, 1. And my slope, which is m, is negative 2, which actually be negative 2 over 1. So those are the two things I need to plot my graph. So start at the point 0, 1. And then I go from here, I go down 2 because my slope is negative 2. And I go to the right 1 because it's a positive 1. You can even go up 2 and then to the left. And then draw your straight line. So now we graph the equation, y equals negative 2x plus 1. Let's moving on. We want to graph the linear function for f of x equals 2. Remember, f of x equals 2 is a horizontal line. Through the point 0, 2. Let me draw a straight line through that. All right. Example 3. Analyzing a company's cost, revenue, and profit. A company produces DVDs of live concerts. The company pays $200 for advertising the DVDs. Each DVD costs $12 to produce, and the company charges $20 per disc. Express the cost of C as a function of S, the number of DVDs produced. Express the revenue R as a function of X, the number of DVDs sold. And when the company breaks even, that is, for what the value of X does revenue equal cost. So we're going to look at all of these three and apply them to this real world situation. So for example 3, 2 of 3, these is 2 or 3 slides. It says blank is $200. For each DVD component, the blank is $12. So we look back at our problem, the fixed cost is $200. Because that's how much they paid to start advertising DVDs. For each DVD, the variable cost is $12. The cost C can be expressed as a function of X, the number of DVDs produced. So we can say C of X will equal 12X plus 200. Each DVD sells for $20, so the revenue is given by R of X equals 20 times X. So remember, X is the independent variable. We will determine Y or R of X once we know how many DVDs are sold, which will be X. For part C, the company will just break even, no profit and no loss, as long as the revenue just equals cost, or C of X will equal R of X. This is true whenever we have C of X. C of X was, and I'll write it up here. So CX, remember CX equals 12X plus 200, and RX equals 20X. I want to start out by subtracting 12X from both sides. And that leaves you with 200 equals 8X. Dividing both sides by 8. Therefore, X equals 25. So if 25 DVDs are produced and sold, the company will break even. Let's move on. Linear models. A linear model, given data points that lie approximately on a straight line, we can develop a linear function, linear model to describe the data. So example 4, tuition costs. The average annual tuition and fees for in-state tuition are given in the table. Look like this is written twice. So I'm going to scratch that out. So the average annual tuition and fees for in-state tuition are given in the table. So when X equals 0, the cost in dollars is $31.56. In 2018, when X is 0, it's $32.42. When X is 2, Y is 3,312. When X is 4, it's $3,501. And this is only the average tuition and fees for out-of-state tuition. Remember, this is the average annual tuition and fees for in-state tuition given in the table below. So we're going to graph the data, letting x equal 0 and corresponding to 2017, where x equals 1, it corresponds to 2018, and so on. What type of equation might model the data? Okay, if you say a linear equation, you are correct, because it's similar to a straight line. Not 100%, but it's close. So to find a linear function that models the data using the information for years 2017 and 2021, since the points lie approximately on a straight line, we can write a linear equation that models a relationship between x year and y cost. Use the two data points for 2017 and 2021 to find the scope of the line. So if we look back at 2017, it's when x equals 1. We have this order pair here. So in 2017 is when x equals 0. We have this order pair. And in 2021, that's when x equals 4. My y value was 3,501. So now to find the slope, we use those two numbers. We take the difference of the y's. Because remember, we have x1, y1, x2, y2. So now we substitute that into the slope formula. Remember, slope equals y2 minus y1 divided by x2 minus x1, which is what is solved in the table here. So subtracted our y values, or the difference between my x values, and get 345 divided by 4, which is 86 and 25 hundredths. So therefore, 86 and 25 hundredths is the slope of the line. The slope 86 and 25 hundredths indicates the cost of tuition, and the fees increased about 86,025 cents per year from 2017 to 2021. We use the slope and the y-intercept, which was 0 and 3,156, and slope-intercept form to write the equation. So remember, when x equals 0, you have our y-intercept, that where b is 3,156. Your m was 86/25 hundredths. So your equation slope-intercept form, you want to replace our b and our m. So it'll be, remember, we're not using y anymore. We're using f of x. So f of x equals the slope, which was 86 and 25 hundredths, x, plus the y-intercept, which is 3156. And this is your final answer. So using the equation from Part B to approximate the cost of tuition and fees at a public 2-year college in 2022. The value x equals 5 corresponds to the year. Let's go back to it. We're looking at the equation that we just wrote. So we're going to use this equation to find the value when x equals 5. So we're going to use the equation f of x equals 86 and 2500ths x plus 3156. So I want f of 5. So 86 2500ths times 5 plus 3156. All right, so when I multiply this gives me 431 and 2500ths plus 3156, which equals $3,587.25. So we can say f of x was approximately $3,587. So according to this model, we want, again, the value x equals 5 corresponds to the year 2022. And when we solved it, we got f of 5 equals $3,587.25. According to this model, the average tuition fees for in-state students at a public two-year college in 2022 were about $3,587. This concludes our unit. I assigned you Pearson, so you'll be working on Pearson 8.4 practice. Again, the Pearson assignment is 20 points. And it's due Tuesday. All right, you have Delta Math tomorrow and the following day. And you'll take your test on Thursday along with your notebook check. Remember your Pearson practice. Make sure that this is number 64. You're showing work on loose leaf. As you're working, let me know if you have any. If you work as you're working, let me know if you have any questions, if you don't understand anything that I explained.